All right, everybody, let's talk for a minute about the string method of metric conversions. So the example we have here is 75 milligrams per deciliter. So when would we use this in the lab? Well, in this case, let's say that we're working with reagents, and we have a concentrated reagent that we want to make a large volume reagent from. So we know that our concentration should be 75 milligrams per deciliter, but since we need a larger volume of this reagent, we want to make a liter. And this is when this conversion would be very useful for us. So we have 75 milligrams per deciliter, and we want to go to liters, milligrams per liter. So I'd start with my 75 milligrams for my string theory over 1 deciliter, because that's my concentration that I have. Now I know that I want to go to liters, and then I want to cross out my deciliters. I want those to cancel. So if you look back at your timeline, we know that 10 deciliters is equal to 1 liter. So we can cross out our deciliters, do our multiplication, and we find out that 750 milligrams per liter would be the correct concentration. So this is an example of string method, and we can continue on with string method to get us to whatever concentration we need as long as we're using our conversion factors. So let's look at another example where we would do more than one conversion factor. Let's say we had 32 milligrams per microliter, and we wanted to know how many grams per liter that is. So that's a two-part conversion because we need to change our milligrams to grams and our microliters to liters, correct? So it would be 32 milligrams over 1 microliter. And then you can choose whichever you would like to convert first. In this case, we'll go with milligrams first. So we know that 1,000 milligrams is equal to 1 gram. And you can take a look at that on that timeline again. And as far as microliters go, we know that 10 to the negative 6th microliters is equal to 1 liter. And again, you can take a look at that timeline to get your conversion factor. So we cross out the units that we don't want, do our multiplication, 32 times 10 to the negative 6th over 1,000. So there are a couple ways that you can divide that out from there. I would divide my 32 by 1,000. So you'd go 1, 2, 3. So it would be 0.032 times 10 to the negative 6th grams per liter. And then we can change this to scientific notation to make it a little bit easier. So in scientific notation, you want the decimal point to be with 1 ahead of it. So we would go 1, 2, so it would be 3.2 times 10 to the negative, and then we would go this way, 10 to the negative 4th grams per liter. So that's two examples of string method. And as you can see, just depending on how many you need to change, you can continue to string out your results until you get the necessary concentrations.